Today, we will prove that there are exactly 3 regular polygons that tessellate the plane. But first, we're going to clear up a few vocab words. A regular polygon means that all polygon is a polygon that has all the same angles and the same sides. A tessellation of a flat surface is the tiling of a plane using one or more geometric shapes with no overlaps and no gaps. And a plane is a flat surface that extends infinitely without edges. We are going to prove that the 3 regular polygons that tessellate a plane are equilateral triangles, squares, and hexagons. So we're going to prove that equilateral triangles tessellate the plane. In order for a polygon to tessellate a plane, 3 things must be true. Every interior angle of each tile, which a tile is the polygon, so for this example, it would be the equilateral triangle, is a factor of 360 degrees. Since this is an equilateral triangle, the sum, or the interior angle, each interior angle is 60 degrees. And since 60 degrees is a factor of 360 degrees, then an equilateral triangle would work for the first point. The second point is the interior angles have equal measures. Since it's an equilateral triangle, then that means that all of the measures are the same, which that would prove our second point. And then the sum of the interior angles is 180 degrees times n minus 2. And the sum of a triangle is 180, so that would prove our third point. So this means that equilateral triangles can tessellate the plane. For our second proof, we're going to prove that squares tessellate the plane. So this example proves our 3 other points we were talking about. Every interior angle of each tile is a factor of 360 degrees. 90 degrees is a factor of 360 degrees. Also, this squares interior angles all have equal measures. So all the squares interior angles have equal measures, and the sum of the interior angles is 180 degrees minus n minus 2. And the sum of the interior angles in a square is 360 degrees, which would make our third point true. Then our last point, each vertex is surrounded by congruent angles, is also true for this tessellation because all of these angles equal 90 degrees, which makes this point true. So now we're going to prove that hexagons tessellate the plane. And as we've talked about those 4 points are also true for hexagons. Each vertex is surrounded by congruent angles. Every interior angle of each tile is a factor of 360 degrees. The interior angles have equal measure, and the sum of the interior angles is 180 degrees times n minus 2, which means that hexagons can tessellate the plane. So in order for an n-gon to tessellate the plane, the vertex is surrounded by congruent angles. Every interior angle of each tile is a factor of 360 degrees. The interior angles have equal measures, and the sum of the interior angle is 180 degrees times n minus 2. Therefore, the only n-gon that would work for this proof would be equilateral triangles, squares, and hexagons. We have an example of a polygon that would not tessellate the plane, which would be a pentagon, because the vertex are not surrounded by congruent angles, which would not tessellate the plane. And our last example is a picture of a tessellation of equilateral triangles, squares, and hexagons that all tessellate the plane.